Today we'll discuss about graphical representation of frequency distribution or the data. So first we should know why we need to present the data graphically. There are three main reasons for graphical presentation. That's by graphical presentation, data can be known at a glance. That means in a single view we can make the comparison or we can make any kind of decision about the data. Here the comparison terms came. That means by graphical representation we can make comparison of the data, and the main thing is the user of the data can understand the data easily. There are many kind of graphical representation. We represent the qualitative variable by bar diagram and the pie chart, and for the quantitative variable we use histogram, frequency polygon, Ogive curve and streamlight diagram, etc. So in this lecture we'll discuss about all this graphical representation elaborately. Graphical representation that represent categorical data with rectangular bars with height or length proportional to the values that they represent. That means a bar graph is consist by some bars. In a short sentence, bar represent the variable value, and there are some kinds of bar diagram, and the commons are simple bar diagram, multiple bar diagram, component or subdivided bar diagram, and the last one is percentage bar diagram. Without wasting much time, let's start some examples. We can see a simple data here that represent the number of students or boys of a section. There are 15 students in section A and 10 students in section B, and the same for section C. How can we represent this data graphically with bar diagram? For this reason, first we have to draw x-axis and y-axis. That's here, it's x-axis and this is the y-axis, and we can use any axis for the category, and the another axis will be used for the variable values or the frequency. Remember one thing, that the length or the height of the bar must be 15, because from the definition we know that the length or height proportional to the values, or the length or height represent the value of the variable. So the height of this bar for A section must be 15. That means it looks like something this. And the section B, let's represent this by vertical bar, and the height of this bar must be 10 because the frequency for section B is 10. So here the height is equals to 10. The width of these bars doesn't make any sense here. But the important thing is you have to make the gap between the two bars. For section C, if we draw a bar, the height of the bar should be equal to V, because the frequency of those sections are equal. Here, a simple data like this, like the earlier one, and here we present the number of girls of this same section. And the number of girls is, for A section is 10 and for B is 10, and 15 girls student in section C. So if we draw this diagram, or if we use bar diagram for this data, then it will look like this. Here these values are 5, 10 and 15. So this bar is for section A and this bar is for section B, and last one is C, and the height of section A is 10. That means the number of girls of section A is 10. So here in the y-axis we represent the number of girls, and the x-axis represent the categories. And same thing for this graph. Here we are representing number of boys in y-axis, and in x-axis, and this is A, B, C category, and x-axis we describe the category. One thing must be noticed, that these two data are same data. In a view, this two data is not different at any sense. Just write down here the data of boys and just write down here the data of girls. And it will be easier to make any comparison or understand this data if we plot them in a single graph. That means if we make a distribution like this, where we write down the data for boys and girls in a single graph, and we can easily say that in A section there are 15 boys and 10 girls, and we get comparison here that here the number of boys is more than girls, and in section B the number of boys and girls are equal, and the section C girls are more than boys. So if we want to represent them graphically, then we can represent them in these three ways. Let's have a look in the first graph. Here what I have done, I just put this second graph in the upper side of the first graph. You can see that here this data or this bar has 15 as its length, which is equals to the number of boys of a section, and these are equal, and the upper portion is equals to number of girls for a section. The length of this bar is 10, which is equals to this. That means I just have put this graphical representation in the upper side of the first graphical representation, and by doing this we can easily make comparison and we can understand the graph at a glance, and it is easier. And this process is called as component or subdivided bar diagram. That means you can write in here subdivided bar diagram, where this bar is representing section A, and this bar is section B, and this is section C, and the lower portion of this bar is representing the number of boys, and this portion is representing number of boys, and the upper side of the bars is representing the number of girls, so that we can make the comparison easily and we can understand the ratio of the number of girls and boys. So let's have a look at the second one. In this portion you can see the scale or the height of this bar is 100, and the height of all the bars is equal. Can you make any guess about this bar diagram? Okay, let me help you. Here we have a data in which we write down the percentage of boys and the percentage of girls of the individual sections. That means we represented the data at the percentage. And look at here, the height of 3 bars is equal, because for all the data, for all the categories, total percentage will be 100. And from this data, if we find out, if we measure the percentage for the boys and girls, it will be, for section A, percentage of boys is 60 and percentage of girls is 40. You can easily find out the percentage by divide any individual data by the total number of observation or total number of variable value, and then multiply it by 100. That means here the percentage for this data is equals to 15 divided by total number of observation. Here is 15 plus 10, that is 25 into 100, and it's equals to 60. And by doing this process, we found all these variable values, and let's put it here. For section A, we consider it as section A, then percentage of boys is 60. So the height of the lower portion will be 60, this portion will be 40. If we consider this bar as B section, then the percentage of boys must be 50, and the percentage of girl is also 50. And if we consider it as C section, then the percentage of boys is 40, and the percentage of girls is 60%. So this we can make bar diagram is known as percentage bar diagram. Percentage bar diagram. For the first diagram, we put the data of girls in the upper side, the data of boys. Here we have put bar for girls beside the bar for boys. If we consider this as a section, then 15 boys are in A section and only 10 girls are occurring in A section. And one thing to be noted, that there are no gaps between the bar for boys and girls, but there are gaps between the section. So you can make a decision that gapping are used only for the categories, not for the variables. So you have to make gaps only for the categories. Here the categories is section A, section B and section C. For section B, number of boys is 10, which is same for the girls, and the number of girls is also 10. And for section C, number of boys is 10, but the number of girls is 15. It just look like. This graph is known as multiple bar diagram. So here we have learned about subdivided bar diagram, percentage bar diagram and multiple bar diagram. And at the first time we already learned the simple bar diagram. These are the simple bar diagram. Now we'll discuss about pie chart. So what is the pie chart? Pie chart is a circular statistical graph which is divided into slices to illustrate numerical proportion, and the arc length or the angle of each slices represent the quantity of a category. And it's almost like the bar diagram, and the difference between them is in bar diagram we use rectangular bars to represent the data, and here we are using the angle in a circle to represent variable values. So let's have a example. Here we have a data that refers the number of people of a office occurring from another area. Say there are 12 people who is falling in area A and 8 people from B, 10 people is from C area, and from D area there are only 6 people. The total number of people is 36 of this office, and we have 4 areas. So how can we represent it by pie chart? We know in pie chart we have to use a circle, as we know that it's a circular graph, and in this circle we have to represent the frequency or the number of people by angle or arc length. So first we have to find out the angle for this data or for this frequency, then we have to represent it in the circle. So how can we find the angle for the peoples? Let's first find the angle for a single frequency. As we know, the total angle of a circle is 360 degree, which is for total number of people, that is 36. So angle for a single number of people will be 360 degree divided by 36, that is 10 degrees. So by doing multiplication this 10 degree with all the frequency, we'll get the angle easily, because we found the angle for a single frequency. And for the angle for 12 people will be 12 into 10, that is 120 degree, and 8 into 10 is 80 degree, and 10 into 10 is 100 degree, and 6 into 10 is 60 degree, and the summation of the angle must be 360 degree. And the main part is how can we represent these angles in the circle. So for this reason we can take the help of this instrument, geometrical instrument, and I hope that all of us will know about the use of this instrument. So for the first data we have the angle which is 120 degree, so we'll mark this area and then add them. So this angle is 120 degree and it's represent area A, and from there for area B the angle is 80. Let's mark it here and let's add those dots, and this angle is 80 degree and it's representing area P. And from here for area C the angle is 100, so let's mark it here, and by adding those points we'll get a area consists of 100 degrees, and this area is representing C, and the other must be the 60 degree and it will represent area D. So here it is the pie chart of this data. It is too simple to make a pie chart. Now we'll discuss about the histogram. So what histogram is? Histogram is a bar graph that represents a frequency distribution of quantitative variable. The width represents the range and height represent corresponding frequency. It's almost same as the bar diagram. The difference is in the bar diagram there were space or gap between the categories, but in the histogram there are no gap between the categories or the values or the rectangular bars, and the bar diagram represents the qualitative data and histogram represents the frequency distribution of quantitative variable or quantitative data. And in the bar diagram there were no meaning of the width of the bar, but here the width represents the range of the class of the data or of the frequency distribution. So here we have the frequency distribution. As you can see, we took two frequency distribution here. One is inclusive and the next is exclusive. So what is the difference of inclusive and exclusive frequency distribution? For inclusive method frequency distribution, we are representing the class marks for the bars, and the bars height is representing the frequency of this class. Here the height of this bar is 5. That means the frequency of this class must be 5. So in the inclusive method we learned about the histogram, and for the exclusive method the histogram should not need any class marks, because here the upper limit of a class is equals the lower limit of its next class, and the frequency of the first class is 5, and the height of the first bar is also 5. That means the height of the bars is representing the frequency. And the second class, which is 30 to 40, and in this class the height of this bar is 7. That means the frequency of the second class is 7. It's like the third class consists of frequency 3, and the height of the third class bar is also 3, and the last one, which is 50 to 60, with corresponding frequency 8, and the height of the bar for this class is also 8. Here you can see it. So this is a simple bar diagram for quantitative variables, and it's called histogram. So here, if we identify the middle point of the bars like this and add them, we can see the increasing and the decreasing portion of a frequency distribution, and this called a frequency polygon. Frequency polygon is nothing but a graphical representation of frequency distribution that makes us understand about the increasing portion and the decreasing portion of a graph. If we put the values in the graph, then the mid value of 25 is here and the frequency is 5, so the frequency for 25 must be 5 and it will be here, and the frequency 7 corresponded to the mid value of 35, that means the 35 and the frequency 7, and the next point is here, and the third mid value is 45 and the frequency of 8 is 3, so the point will be here. The last one, mid value is 55 and frequency 8, that means 55 is 8, so it's here. And if we add those points like this, let me write it with pen. So by this graph you can easily know increasing and decreasing part or decreasing portion of a frequency distribution. Here if we write this point as letters, then we can say that the graph is increased from A to B and decreased from B to C and again increased from C to B. as a middle value is 25, that the earlier middle value of the class should be 15, and we also can add this point with it, because there are no frequency for 15, so it is 0, and as like 55 the last mid value and the next mid value of it should be 65. Let's consider it here, and there is no frequency of 65 or of the class of 60 to 70, so we can also make a join of these 2 points, and this is the complete frequency polygon, and that's too much easy. What you have to do, you have to just find out the mid value of a class and the frequency, which is also given of a frequency or to a frequency distribution, and then just design these points in a graph and add them, and you will get a frequency polygon. This too much. And the cumulative frequency polygon is also known as Ogive curve. That is almost the same as frequency polygon. And the basic difference is in frequency polygon we put the values of frequency in the graph, and here we'll put the value of cumulative frequency and decumulative frequency in the graph. And here we have a graph, and in the x-axis we represent the mid values, and in the y-axis we represent the cumulative frequency and the decumulative frequency. Let's make the graph for cumulative frequency. For 15 there is no values, so it's 0 and 25. Cumulative frequency is 5, that means it will be here. And for 35 the cumulative frequency is 12, that means it will be here. Doing the same process for the other points, and let's join the points. This is the Ogive curve for the cumulative frequency. Let's input the decumulative frequency as a graph. For the point 25 the decumulative frequency is 23, that means it will be 23 and it will be here. And for 35 the decumulative frequency is 18, that is here. Doing the same process for the other points, and let's join the points. It will look like this, and this is the Ogive curve of cumulative frequency, and this is decumulative frequency Ogive curve. A stem plot is a type of chart that shows how individual values are distributed within a set of data. That means it's a way of summarizing a set of data measured on an interval scale. In stem and leaf diagram, stem refers to all the others number except the last, and the leaf refers to the very last number of a variable value. Let's take an example that if we take a number that is 61, then 1 will be the leaf of the variable value and 6 will be the stem, and same for 171. The 1 will be the leaf and 170 will be the stem. So now let's take a data and make a stem and leaf plot. So here a data of expenditure of girls for ice cream. This is the daily expenditure of girls for ice cream. The stem will be written in the center with a vertical line besides it, like stem will be written here and with a vertical line beside him. And as we know, stem refers to all the others number except the very last number. So here for 15 the very last number is 5, so that the 5 will be the leaf and 1 will be the stem. So here 1 is the stem, and we can see for this 4 value 1 is the stem, and the next is 2 is the stem, here 3 is the stem, 4 is the stem, and finally 5 is a stem. And how can we write the leaf? We write the leaf the side of the stem, and leaf refers the very last number of a variable value. So in this variable values, for the first value the very last number is 5, and it will be written with its corresponding stem, that is 1. So I'll write it here, then it's 8, then it's 5 and 6, and you can see there is a value which is 22, and here 2 is the leaf of this value, and it will be written with its corresponding stem, that is 2, so we'll write it here, and then 3 and 9. And further here we can find 3 as the stem and 2, 4, 9 as its corresponding leaf. That means 2, 4, 9 is leaf of stem 3. For the further 2, 3, 6 are the leaf for the stem which is 4. So let's write down it here. And finally the leaf of the stem 5 is 0. There's another stem plots that's called back-to-back stem plots. That's the option for comparing data from two population or two sample. That means here you can see the expenditure for ice cream of girls, and also you can see the expenditure for ice cream of boys. And if we want to represent both of this data in a stem and leaf plot, for this representation we can use another vertical line on the other side of the first used leaf, and in this side we also can write the other values as a leaf. So as you can see, the first value is 0, 5. That means the stem is 0 and the leaf is 5. So we have to add a stem here, and the leaf for this stem is 5. And there is no other value for its stem is 0. And we can see in the next values having stem 1 and leaf 2, 6, 8 and 4. Having stem as 2, there are leaves 1, 3, 5, 5, 5 and 7 and 9. Let's write it here 1, 3, 5, 5, 5 and 7 and 9. And having stem is 3, there is only one leaf, that is 0. And there is no leaf having stem 4 and 5, so we don't need to write down here. So by doing this process we can easily make a stem and leaf plots and back-to-back stem and leaf plots. In the next video we'll talk about the central tendency and its measures.